Hello, my dear students. So, subject basic electrical engineering and model 2 single phase circuits we are dealing in last class. We were dealing in last class. So, because of this corona effect, uh, totally we have under the lockdown condition. So, in this period, so I am thinking it is better to uh, conduct classes in this way. I will make the videos like this and I will upload to my YouTube account. So whenever you are free, you can go through these videos for further studies. Instead of sitting quite in home, you can go through these videos. Uh, you will be in touch with the subject. So in last class, we were dealing with the single phase circuits. In that, we have studied the single phase AC circuits. In that AC circuits containing pure R, AC circuits containing pure L and pure R. AC circuits containing pure R circuits. These things we have studied last class. And AC circuits containing pure inductor circuit and AC circuits containing pure capacitor. These three derivations we have studied last class. Out of these three, these two are much important derivations from your exam point of view. You would be practice these two. Better you practice these two, will come to know the in exam you may get these questions. So in case of pure resistance, what you have got, we have given the V is equal to Vm sine omega t is the supply given. So pure R is the R. It is again V is equal to Vm sine omega t is the input supply is given, and it is L. So voltage across L is VL, and supply given here V is equal to Vm sine omega t. It is same in all cases. It is capacitor is C and voltage across that is Vc. That is the Vc. In case of pure resistance, so it is the current flow in all three cases. Current flow in all three cases. So like this circuits we have studied in last class, and even in case of vector diagram, if you want to draw, or you can say phasor diagram, if you want to draw, you can draw like this. In case of pure resistance, as I have studied, V is in phase with the current. V is in phase with the current. So it is the VR, resistor voltage across the resistor. VR in phase with the I, starting from 0. In case of inductors, what happens here is that, so we know that, so in case of inductor, current lags the voltage by angle 90 degree. In case of pure inductor, it say it is V, it is I. So VL, it is 90 degree. So current lags the voltage by angle 90 degree with respect to this voltage. In case of pure capacitor, again it is in this case current leads the voltage by angle 90 degrees. So it is the current flowing through the capacitor I, and current through the capacitor is VC, we can say. So it makes the angle 90 degree. In case of capacitor, current leads the voltage by angle 90 degree. In case of pure inductor, current lags the voltage by angle V. In case of pure resistors, current and voltage both are in same phase. Both are in same phase. This much we have studied in last previous classes. And what about PV, power developed here? Instantaneous power is equal to V into I. We have studied V nothing but what? V RMS, I RMS. In case of pure inductor, P is equal to 0, we have got. So in case of pure capacitor, we have got the 0. Instantaneous power dealing with the pure inductor is 0. And similarly, in case of with respect to capacitor, it is 0. So these things we have studied last class. And V is equal to what is that? V is equal to Vm sine omega t, we know. And same in all three cases, V is equal to Vm sine omega t. V is equal to Vm sine omega t. What about current equation? Current is equal to sine Im sine omega t, because both are in same phase. Both are in same phase. In case of pure inductor, I is equal to Im sine of omega t minus 90 degree. In case of pure capacitor, I is equal to Im sine of omega t plus 90 degree, because it is leading, it is lagging, it is in same phase. Like this, we have last class, we have studied regarding the single phase circuits, pure R, pure L, pure C circuits. So next class, now we shall deal with the next derivation. So AC circuits containing pure AC circuits containing R and L in series. AC circuits containing R and L in series. In this diagram, in this we can draw like this. It is the resistance R and inductance L, both are in series connected to one supply, AC supply. It is like this. So AC supply is equal to Vm sine omega t, and it is R, it is L. So voltage across resistance, say it is VR, voltage across inductor, say it is VL. So current flowing, I is flowing through the circuit. So it is the AC circuits containing RL in series. In this, so how to draw the phasor diagram here? How to draw the phasor diagram we can draw like this. As you have studied in previous classes, pure R, pure L and pure C. Similarly, those things we have to combine here and make the another vector diagram or phasor diagram. How to combine this one? First, we have R here. In case of R, resistance, current and voltage both are in series. Both are in series or in same phase. Say it is VR and current I. Both are in same phase. For a pure R it is. Next, inductor. Inductor is in lagging. Inductor, in case of inductor, current lags the voltage by angle V. Lags the voltage angle by V. We can draw like this. We can draw like this. Say it is VL, because current is here and VL is here. Current lags the voltage by angle 90 degree. Like this we can draw. It is the VR, voltage across resistor. It is the L, voltage across inductor. It is VR and it is VL. We can make here. So as per the Pythagoras theorem, we can create one triangle here. So it is called as, so these two are the sides. These two are the, this is the, we have got, it is a total V, we can say. Total V, we can say it is making angle phi. It is making angle phi here. So it is the, according to Pythagoras theorem, we can write here, right? So it is the VR square plus VL square is equal to V square. That you can draw here. So as per this diagram, what you can say, AC circuits containing AC circuits containing R and L in series and supply of V is equal to Vm sine omega t. So voltage across resistance is, voltage across resistance R is VR. Then voltage across inductor L is VL. So we can, according to this triangle, so you can name it as O, it is A, it is B. According to triangle, from triangle O A B, from this triangle OAB, so we can write like this. According to Pythagoras theorem, OA square is equal to OB square plus OA square. What is OA square here? It is V square. It is VR square plus VL square. So it is, what is VR here? VR nothing but what? I into R whole square. VL nothing but what? I into XL whole square. It is V square. So it is I square R square plus I square XL square. Can take I common, can take I square plus XL square. It is V square. So next is I am taking the square this side, it will become square root. V is equal to under root I square R square plus XL square. So it will become I under root R square plus XL square. So we can write this R square plus XL square as like this. Z. So current will be equal to V by Z, where Z is equal to, where Z is the impedance. Z is the impedance. That is the impedance. So impedance nothing but it is the combination of R and L. So it is the combination of R and L here. So like this we can derive the equation of current like this. Where Z nothing but what? It is the impedance. So you can write Z is equal to under root R square plus XL square. R square plus XL square. So now this much we have got. Now we have to draw the waveform here. We have to draw the waveform. How to draw the waveform here? In this case, so it is a time period omega t. So it is the maybe current and voltage. Both we are drawing both current and voltage. We are drawing. We are starting from 0. So first we shall draw the voltage waveform, which is directly we can draw here. It is the voltage waveform. So it is 0, it is pi, it is 2 pi. So in middle it is making pi by 2. So it is making 3 pi by 2. So like this we can draw the voltage waveform. Next we can draw current. Current is making angle how much? It is making angle, it is making angle phi. So in this, in pure L it is making angle 90 degree. My dear friends, you remember here, in case of pure inductor, it is making angle 90 degree. But in this case, it is not pure inductor. It is a combination of R and L. It is a combination of R and L. So that's why it is less than that. It is not 90 degree. It is less than that. How much it is? It is the 90 degree. It is not, sorry, how much it is? It is angle phi. How much it is making angle, how much it is lagging? It is lagging the voltage, it is lagging the current, lagging the voltage by angle phi. Remember this one. In case of RL combination, in case of RL combination, current lags the voltage by angle phi. Current lags the voltage by angle phi. It is the total current, it is the total voltage. Current lags the voltage by angle phi. Like this we remember how to draw here. It is making angle phi. It is not 90 degree. It is not 90 degree. It is making angle, some angle phi here. It is angle phi. It is angle phi. It is lagging. First voltage is starting. It is the first voltage. After that, current V is equal to Vm sine omega t. Or this one can write this one, I is equal to Im sine of omega t. How much it is? Angle phi. Like this you can draw here. It is making angle phi with the voltage I. So V can write as V equal to Vm sine omega t, and I is equal to Im sine of omega t minus phi. Like this we can draw the equation. Current equation and voltage equation. This is the waveform. It is the waveform. Next we have the instantaneous power calculation. Next is the instantaneous power calculation. Instantaneous power calculation we have to make. So what is the power equation? Power P is equal to V into I. So what is P here? Vm sine of omega t into Im sine of omega t minus phi. So we can multiply here. It will be my Vm into Im sine of omega t into sine of omega t minus phi. Like this you can write. So it will be in the form of sine A into sine B. Sine A into sine B. So we know that sine A into sine B is equal to, we have one formula. It is 1 by 2 cos of A minus B minus cos of A plus B. Remember this formula. Sin A sin B is equal to 1 by 2 cos of A minus B minus cos of A plus B. If you apply this formula, we'll get like this. So 1 by 2 sin of omega t minus phi, where A is the omega t now, B is the omega t minus phi. So it will be equal to cos of omega t minus omega t plus phi. So you try mathematically, you take a time and you just try it. Minus phi, this much will get. So it will be equal to 1 by 2 omega t minus omega t will cancel here. We'll get the plus phi, cos of phi minus cos of 2 omega t minus phi. So we have to consider only, we are not considering this part because it is the fluctuating. It is the fluctuating. That's why we are not considering this one. We are considering only cos phi. So P equation will become P equal to Vm Im 1 by 2 cos phi. So you can write like this: Vm by 2 Im by 2 cos phi. It can write like this: Vm by root 2 Im by root 2 cos phi. So that will be equal to, P will be equal to V RMS I RMS cos of phi. So in case of pure inductor, in case of R and L series, so instantaneous power will be equal to V RMS I RMS cos phi. So this much we have got in case of instantaneous power. So it is the I can say it is the derivation for series RL. To the derivation for series RL. So you note down and practice this derivation. So in this case we have circuit diagram is present, and after that explanation is present, and from that we have to get the equation of impedance, and this the phasor diagram is also important. Phasor diagram is important. After that we have the waveform here. After that there is a instantaneous power equation. So all these are important. diagram. All these diagrams and equations are important. You practice all these things.